Some superb model steam plants for sale, also featured in the video series when I constructed them, and there are text links on the video header. And now it's time for a proper steam test. That's the burner lit, and as you can see in this clip, when the burner's first lit, the flame is blue, but the ceramic head of the burner soon turns red as it warms up. There is some water in the boiler, but it does need a bit more. So here I'm filling the reservoir tank with water, and I'm going to pump some more of this into the boiler. Normally I wouldn't replace the lid, but seeing as it's for the video I did. And here's the hand pump at double speed, pumping the water into the boiler. As usual, while the boiler is raising steam, it's a good idea to lubricate the engine, and the rule for that is use good quality lubricating oil and oil every moving part. Not forgetting to lubricate the inside of the cylinder, and this is done by filling the displacement lubricator. What I've just been doing though is draining the displacement lubricator from the previous run. After draining the water from the lubricator, I refill it with oil and replace the cap and tighten the valve at the bottom. Nothing's shown on the pressure gauge at the moment, but something's happening because there's a little bit of steam and water coming out of the safety valve. To warm up the cylinder of the engine, I opened the steam valve. I rotated the flywheel and it continued to rotate. Let the steam test begin. I thought I would take this opportunity while the pressure is still low to warm up the Siren. There isn't enough pressure here to make the Siren work, and as you can see there's a lot of water coming out of the Siren. The boiler has a steam dryer coil, but by the time the steam gets down the pipe and into the turret, it's not exactly superheated. Now for the proper Siren test. Nothing yet, and that's at £50 per square inch. And now the boiler's blowing off at £60 per square inch, which is its working pressure, and there's still no noise coming from the Siren. A while back I bought this from Microcosm, and this is a bell whistle. It has its own steam valve, but the thread is a little bit too big to fit into the turret, and that's why I used the valve from the first Siren. The reason why the bell whistle isn't blowing at the moment is because the boiler is nearly at working pressure, which is too high for the current physical setting, so I adjusted that. You will notice the gaps in the boiler cladding. This happens as the mahogany strips dry out and shrink. So after this steam test, I moved all of the cladding around the boiler to close these gaps. Then I inserted another piece of mahogany to fill the one big gap that I got at the back. Here I'm checking the amount of water in the boiler by blowing down the water gauge. It was a bit on the low side, so I'm pumping some more water in. What I'm doing in this clip is emptying the condenser. I've connected a piece of silicone rubber tubing to the condenser valve, and by running the steam engine, the exhaust back pressure forces the water out into a suitable receptacle, which in this case is an old biscuit tin. You can see that the water is cloudy because it also has some steam oil in it. Time to give the whistle a test now I've adjusted it. Nothing wrong there, it sounds quite nice. I think a steam whistle is a better idea for this plant because the owner often will be running it on compressed air, and that way his two young sons will be able to play with the steam plant without fear of getting burnt. But that wouldn't have been good for a steam Siren which needs water and steam to lubricate it. There's plenty of water in the boiler, nearly a full glass. So let the steam test begin. I'll light the gas first. I lit the gas by holding my small gas lighter over the chimney, and in this clip I'm putting my hand over the chimney so I can verify that the burner is lit by the heat coming out of the chimney. The first job to do is to make sure that all of the displacement lubricators are filled. Surprisingly, I didn't receive one comment telling me that I got the displacement lubricators the wrong way around. I did it this way so that all of the taps were facing the operator. The only one that is the right way round is the one on the aerial engine, and as you can see, the short pipe from the tank goes to the steam inlet of the engine. And by piping the displacement lubricator valve assembly this way, the valve cuts off the steam to the displacement lubricator, but doing it the other way, I cannot cut off the steam to the lubricator. Once again, the displacement lubricator is fitted the wrong way round on the vertical engine too. You can see the oil bubbling slightly, and there's no real pressure in the boiler yet. The water's just starting to boil. The orientation of the lubricators in this plant is not a problem. The boiler is small, you turn the gas off, and the steam pressure in the boiler quickly drops and goes down to 0. While the pressure is dropping, you open the bottom valve to clear the condensate, and when the pressure's gone, remove the top cap to refill the lubricator. Now the pressure is rising rapidly. By opening this valve that's going to be used for compressed air inlet into the boiler, you can see that there's steam coming out of it. So as soon as I've lubricated all the moving parts of every engine, and I'll do this at high speed just to make it a quicker process, it's finally time to start the test. I open the steam valve to the small vertical engine, and that works okay. Then I open the steam valve to the aerial engine, and that works fine too. And with a quick flick of the flywheel, the Perseus engine bursts into life also, but the other two stop. It's a bit of a balancing act to get all the engines to run together. The boiler's quite small and immediately the pressure drops, but these engines are not under load, they work quite well. The pressure drops fairly quickly, but the engines keep going, which is a good thing. I'm going to pump some water into the boiler to see how far the pressure goes down. I have to remember that this is not a Castle Steam V6 coal-fired boiler. It's a very small gas-fired boiler. And when I pump the water in, the engines still run, which is a good thing, and the pressure drops to a very low figure. But nevertheless, the engines are still rotating, which is all that I want really. Ordinarily, I would use string on the steam inlet pipes to these engines, but this steam is really not very hot by the time it's got down these long pipes. And also, white painted string would become very dirty very quickly if any attempt was made to clean the piping. So I think for this plant, the piping, once it's all straightened out, is going to look much better in natural copper. I'm going to remake the pipe run from the water tank to the hand pump because it's a bit too long and I had to put a kink in it, and I don't like that. But the good news is, all of my copper pipe runs do not leak. This red vertical engine, named after the Egyptian goddess Isis, needs the piston rod repacking because it's leaking water a bit. I will do this tomorrow as I make some fine adjustments to the plant before the owner picks it up on Thursday evening. Well, I found a leaky pipe which I'll have to re-silver solder. That's a bit of incompetence, and that is incompetence, not incontinence once again, on my part. And in this clip, I've opened the valve to the pump, which immediately hydraulic locks because, as I've just mentioned, The first steam that hits a cold engine condenses to water, but in no time at all it clears and the pump starts to move. At the moment the water bypass valve is open, so all of the water will be going into the tank, coming from the tank, through the pump and back to the tank. Apart from that leaky pipe, everything seems to be fine.